The shift whistle at the Detroit tank arsenal blew at 5:45 in the morning. It could be heard 2 miles away, across the flat suburban landscape of Warren, Michigan, past the Victory Gardens and the rows of warworker housing that had gone up almost overnight. Inside the plant, the first shift was already moving. Not walking. Moving. There was a rhythm to it, a pace enforced not by foreman but by the assembly line itself, by the chain that never stopped, by the fact that the man behind you was doing his job and expected you to do yours. The building was enormous. 1 million square feet under a single roof, the largest manufacturing space in the world when it opened in 1941. It had been designed by Albert Kahn, the same architect who had built the Ford River Rouge complex, a man who understood that light and air were not amenities in a factory but requirements. Skylights ran the length of the roof. The floor was concrete, 6 inches thick, reinforced to carry loads that would have broken lesser foundations. The overhead cranes moved day and night, swinging steel components that weighed more than houses from one station to the next. 22,000 people worked there, spread across 3 shifts. They did not build aircraft. They did not build ships. They built the M for Sherman tank, the vehicle that would eventually roll through the hedgerows of Normandy, across the desert of North Africa, through the streets of liberated Paris. They built it 1 station at a time, 1 shift at a time, 7 days a week, without stopping. Before we go further, if you are drawn to stories like this one, to the people who built the machinery of history rather than commanded it, consider subscribing. These are the forgotten workers, the ones whose names appear nowhere in the official histories but whose hands made everything else possible. The problem nobody wanted to talk about. In the summer of 1940, the United States Army had 464 tanks. Most were obsolete. The M2 medium tank, the best the Army possessed, had a 37mm gun that could not penetrate the armor of the German Mark III at combat range. The Army knew it. The engineers knew it. The tank crews who had read the reports from France knew it. What nobody knew was how to fix it fast enough to matter. The solution, on paper, was straightforward. Build a new tank. Design it around a 75mm gun, give it enough armor to survive most anti-tank fire at typical engagement distances, make it reliable enough to cover 1,000 miles without a catastrophic mechanical failure, and, most critically, make it simple enough to be built by workers who had never seen the inside of a tank factory, because there were no tank factories and there were no experienced workers. The design that emerged was not elegant. British tankers who first received the Sherman in 1942 noted that it sat high, making it an easy target. German engineers, when they eventually examined captured examples, observed that the ammunition storage arrangement made it prone to catastrophic fires when penetrated, a fact that gave the Sherman its grim nickname among the men who died inside them. These were real problems. They were never fully solved. But the Sherman had one quality that no German tank of the era could match. It could be manufactured. Its components were standardized across 5 different production facilities. A transmission built in Cleveland could be mated to a hull built in Detroit and an engine built in Philadelphia. A track pin manufactured in one state would fit a track link manufactured in another. This was not an accident. It was an engineering decision made deliberately, at the cost of other qualities, because the men who designed the production system understood something the critics never quite grasped: a mediocre tank that arrived was worth more than a superior tank still on the drawing board. Chrysler's impossible promise. The contract arrived at Chrysler Corporation headquarters in Highland Park on August 15, 1940. K.T. Keller, the company's president, read it twice. The Army wanted 1,000 tanks. It wanted them within 18 months. It wanted them built to Army specification, which meant tolerances and quality standards that had never been applied to automobile production. And it wanted Chrysler to build an entirely new facility to make them, a facility that did not yet exist, on land that had not yet been acquired, designed to manufacture a vehicle that had not yet been finalized. Keller said yes. The engineers who attended the subsequent planning meetings later described the atmosphere as controlled panic. The tank drawings that arrived from Aberdeen Proving Ground were incomplete. In some cases, they showed components that had not yet been tested. In others, they specified materials that were already in short supply. One senior engineer, a man named Fred Zeder, who had spent 30 years designing automobile powertrains, looked at the proposed 975 horsepower Wright radial aircraft engine that was to power the tank and pointed out that the mounting brackets shown in the drawings would shear under operational stress within 100 miles. He was right. The drawings were revised. Ground was broken on the Arsenal site in September 1940. The building was completed in March 1941, 6 months after construction began. The first tank rolled off the line in April. Not in the numbers the Army wanted. Not to the quality standards anyone was satisfied with. But it moved under its own power, and it moved in the right direction, and that was enough to prove the production system could work. The workers. The hiring office opened before the building was finished. The line stretched around the block in Warren, down Van Dyke Avenue, past the diners and the hardware stores and the church with the sign that read "Pray for Victory." The applicants were men who had worked the lines at Ford and GM and Chrysler, who had spent the Depression making automobile parts at reduced wages, grateful for any work at all. They were also men who had never worked in a factory, farmers from Kentucky and Tennessee who had followed the wartime economy north, following cousins who had followed uncles who had come up a generation earlier. And they were women, in numbers that surprised everyone, including the women themselves. By the summer of 1942, women made up nearly 30% of the Arsenal workforce. They operated drilling machines and milling machines. They worked quality control, measuring components with gauges and calipers, rejecting parts that failed to meet tolerance. They drove the smaller industrial vehicles that moved materials across the factory floor. Management had not planned for this. The bathrooms had not been designed for it. The locker rooms had not been designed for it. Adjustments were made, not gracefully, but made. Dorothy Kessler arrived at the Arsenal in March 1942. She was 23 years old. Her husband was in the Pacific, somewhere she was not allowed to know specifically. She had worked as a telephone operator in downtown Detroit, but the Arsenal was paying $1.80 an hour for line work, nearly double what the telephone company paid, and the work felt like it meant something. She was assigned to Hull Assembly, Station 14, where she joined a crew of 8 workers whose job was to install the sponson brackets, the steel fittings that attached the external armor panels to the main hull. The bracket weighed 11 pounds. Each hull required 22 of them. Each bracket had to be positioned to within 1/16 of an inch, held in place while a co-worker ran a pneumatic drill through 4 bolt holes, torqued to specification with a pneumatic wrench, and then checked with a go-no-go gauge before the hull moved to the next station. The process took, when everything went right, for minutes and 20 seconds. The line moved every 5 minutes. Dorothy Kessler and her crew had 40 seconds of margin. On a good day, they used none of it. The line that never stopped. The assembly line at the Detroit Tank Arsenal was not identical to an automobile line. A tank hull weighed 12 tons. The components were larger, heavier, and less forgiving of misalignment than anything in automobile production. The welding required by the armor plate was a specialized skill that took months to develop, not the spot welding of auto body panels, but deep penetration arc welding in positions that stressed the body in ways that auto welders never encountered. Raymond Duchesne was the chief welder instructor. He had learned his trade in the shipyards of Quebec during the First World War, moved to Detroit in 1923, and spent the intervening years welding boiler tanks and industrial pressure vessels. When Chrysler hired him in late 1940, he was 58 years old and believed, as a matter of professional conviction, that the welding specifications in the Army's tank drawings were physically impossible to achieve at production speed. He was wrong, but it took him 8 months to admit it. The key was the preheating protocol. Armor plate, when welded cold, developed microscopic stress fractures along the heat-affected zone. These fractures were invisible to the naked eye and past visual inspection. But under ballistic impact, they propagated, and a weld that had passed every quality check would fail in combat. Duchesne had seen this happen in pressure vessel testing. He knew what it looked like. The solution was to preheat each section of armor plate to 300 degrees Fahrenheit before welding. This required a separate preheating station, additional tooling, additional time, and additional workers. It added 45 minutes to each hull's production cycle. The production managers objected. Deschênes refused to sign off on the quality documentation without it. There were meetings. There were arguments. Eventually, an Army Ordnance Inspector was brought in. He sided with Deschênes. The preheat stations were installed. The line slowed for 3 weeks while the new protocol was implemented. Then it sped back up, and the weld quality improved enough that the Army's acceptance rate, the percentage of hulls that passed final military inspection, rose from 67% to 91% within 2 months. The 3 weeks of lost production were recovered within 6. Deschênes never spoke publicly about the episode. He considered it a normal part of doing the job correctly. 30 tons, 1 hour. At full production in 1943, the Detroit tank arsenal completed 1 Sherman tank every hour of every day. This number, when stated plainly, resists comprehension. A Sherman tank weighed 30 tons. It contained approximately 50,000 individual components, bolts, bearings, seals, gears, springs, cables, instruments, weapons, optics, electrical connections, track links, drive sprockets, road wheels, return rollers, each one manufactured to a specification, each one required to function reliably in environments ranging from the sub-zero temperatures of the Russian winter to the 130-degree heat of the Libyan desert. The logistics of supplying this production rate were staggering. Steel arrived by rail from Pittsburgh and Gary. Engines came by truck from the Continental Motors plant in Musken. Transmissions came from Detroit Transmission, 15 miles away. Guns arrived from Watervliet Arsenal in New York, shipped by rail across 5 states. Every day, more than 400 tons of material arrived at the arsenal's receiving docks. Every day, roughly 24 completed tanks left through the shipping gates, loaded onto flatbed railcars for transport to Camp Polk in Louisiana or Camp Bowie in Texas, where the crews who would eventually drive them were learning which levers did what. The scheduling of this supply chain was managed by a team of 7 clerks working in a converted office space adjacent to the main plant. They worked with paper forms, telephone, and a wall-sized production board covered in color-coded magnetic tiles. Each tile represented a component or subassembly. Each color represented its status: ordered, in transit, received, in production, completed. The board was updated 3 times a day. The clerks who managed it worked 10-hour shifts and were considered by the plant manager, a taciturn Michigan engineer named Harold Shell, to be among the most important people in the facility. Shell had come up through the Chrysler production system in the 1920s, learning the logic of mass production from men who had learned it from Henry Ford. He understood the difference between a bottleneck and a buffer, between a problem that would resolve itself and a problem that would cascade. When the supply of manganese steel, used in tank track links, tightened in late 1942 due to shipping disruptions in the Atlantic, Shell had already stockpiled a 6-week reserve. When the reserve of engine mounts fell below 2 days' supply in January 1943, due to a miscommunication between his office and the Continental plant in Musken, he drove there personally, identified the problem, a paperwork error in the shipping department, and had the backlog cleared within 48 hours. He did not consider either of these events particularly remarkable. He was running a factory. Factories had problems. The job was to solve them before they became crises. The women who stayed. The popular image of wartime factory women, drawn from posters, from newsreel footage, from the mythology that accumulated afterward, tends toward the heroic and the temporary. Women who stepped in, did the work, and then stepped gracefully aside when the men returned. The reality at the Detroit tank arsenal was more complicated. Many of the women who came to the arsenal in 1941 and 1942 had no intention of leaving when the war ended. They had discovered something. Not simply that they were capable of the work, most had suspected that. What they discovered was that industrial work paid 4 times what they had earned before, that it came with benefits they had never had, that it placed them in a community of people working toward something that mattered, and that the skills they were developing, precision measurement, machine operation, quality control logic, were real skills, portable skills, skills that had value. Eleanor Marsh had been a seamstress before the war, working in a garment factory in Hamtramck for 60 cents an hour. She came to the arsenal in August 1942 and was placed in quality control, measuring tolerances on machine components. Within 6 months, she had been promoted to inspection lead, responsible for a team of 12. Within a year, she was training new inspectors. She was 27 years old, and she was earning more money than her father had ever made in his best year at the Ford River Rouge plant. She was also, without entirely realizing it, developing expertise. The ability to read a blueprint. The ability to use a micrometer with confidence. The ability to identify a machining defect by the pattern of tool marks on a component surface. These were not abilities that disappeared when the armistice was signed. They were abilities that the automotive industry, which was about to expand enormously to meet the pent-up consumer demand of the post-war years, would need. Eleanor Marsh was not offered her job back when the men returned. She was told, politely but clearly, that positions were being held for returning veterans. She found work at a machine shop in Ferndale. The shop's owner, a man named Kowalski who had stayed out of the army due to a heart condition and had spent the war years watching what happened when you put determined women in front of precision measuring equipment, hired her the same afternoon she walked in. She worked there for 22 years. She never talked about the arsenal, not because the memory was painful, but because it seemed to her self-evident, she had done the work. The work had been done. That was the end of it. The count. The final production tally at the Detroit Tank Arsenal, accounting for all variants, all modifications, all the incremental changes that accumulated as the Army and the crews who used the tank sent back reports from North Africa and Italy and eventually France, was 22,234 vehicles. Not all of them were Shermans in the original configuration. As the war progressed, the design evolved. The cast hull gave way to a welded hull. The 75mm gun gave way to a 76mm gun in some variants. The radial aircraft engine was replaced in many production runs by a more reliable Ford-designed V8. Each change required retooling, retraining, temporary slowdowns followed by recoveries. The workers absorbed these changes the way they absorbed everything else, by doing the job in front of them, shift after shift, until the new way became as natural as the old way had been. In November 1944, an Army Ordnance officer named Colonel William Dobbins visited the plant as part of a production review. He had spent the previous 3 months in Europe, observing tank operations in Normandy and Belgium. He had seen Shermans burn. He had spoken with survivors of tank engagements where the Sherman's relative weakness against German armor had cost lives. He arrived at the arsenal with a list of design criticisms and a general disposition toward dissatisfaction. He left 2 days later with a different set of thoughts. What changed his mind was not the production statistics, which he had read before coming. It was a conversation with a line worker named James Okafor, a black man from Alabama who had come north in 1941 following his brother, who had come north following a cousin, who had come north following the simple arithmetic of wages. Okafor had worked at the arsenal for 3 years and was now a senior station operator in final assembly. Dobbins, on a floor tour, asked him what he thought of the tank. Okafor considered the question. Then he said, "The tank does what it's supposed to do, which is get to where it's going and keep moving. The parts fit. The welds hold. We build it the same way every time, so the man who fixes it in the field knows where to look. A tank that always breaks the same way is easier to fix than a tank that surprises you." Dobbins wrote this down. He included it, paraphrased, in his final report. The report was classified. It was declassified in 1972. The passage about Okafor was quoted in an academic study of wartime production management published in 1989. James Okafor was not contacted for comment. He had died in 1971. After the whistle stopped. The last tank built at the Detroit Tank Arsenal was completed on June 25, 1945. The European War had ended 6 weeks earlier. The Pacific War continued, but the Army's tank requirements for a potential invasion of Japan were being met by other facilities. The order to curtail production came with 2 weeks' notice. Harold Shell managed the wind down the same way he had managed everything else, methodically, without visible emotion, with attention to the details that other people were too busy or too distracted to notice. He arranged for the tooling to be properly preserved rather than scrapped. He insisted on a final quality audit of every tank in the completion queue. He made sure the workers who were being let go received their final pay correctly calculated, including any overtime owed. He had always believed that how you ended something was as important as how you ran it. He retired in 1948. The Arsenal was converted to civilian vehicle production, then to defense work of other kinds. The building is still there, in Warren, Michigan. The Army still uses it, under a different name, for different work. The concrete floor that once bore the weight of 30-ton tanks now bears the weight of whatever comes next. Raymond Duchesne died in 1952. His obituary in the Detroit Free Press mentioned his work in shipbuilding. It did not mention the preheat protocol, or the 3 weeks the line slowed, or the 91% acceptance rate. Dorothy Kessler's husband came home from the Pacific in September 1945. She left the Arsenal 2 weeks later when her position was eliminated. She never returned to factory work. Her daughter, in a conversation decades later, said that her mother rarely talked about the Arsenal but kept, until the end of her life, a habit of measuring things, door frames, the gaps around windows, the fit of a drawer, with a precision that seemed instinctive, that seemed to come from somewhere deep, from a period when she had learned that the difference between a measurement that was close enough and a measurement that was correct was a difference that could not be negotiated. What the gauges don't show. The historiography of the Second World War tends toward the dramatic. The turning points, the landings, the battles that determined everything. This is understandable. Drama is how human beings process scale. It is easier to understand Normandy than to understand the fact that the success at Normandy depended on the reliability of transmissions built to specifications maintained by inspectors who learned their trade in converted office spaces in suburban Michigan. But the industrial history of the war, when you look at it carefully, is more strange and more human than the battlefield history. It is a story about what ordinary people can do when the situation removes the option of doing less. It is a story about production workers who became, through repetition and necessity, masters of their craft. It is a story about managers who solved problems not with inspiration but with attention, with the application of steady judgment to a sequence of concrete difficulties. It is also a story about what happened after. About the ways in which the skills and the competence and the confidence that the war produced in its workforce were systematically undervalued in the peace that followed. About women who had proven, beyond any argument, that they could do the work, and who were removed from the work anyway, not because they had failed but because they had succeeded at the wrong time, in the wrong bodies, in a country that had not yet worked out what to do with that fact. The 22,234 tanks built at the Detroit Tank Arsenal are gone now. Worn out, destroyed in combat, cut up for scrap, or sitting in museum parking lots slowly oxidizing back into the earth. The ones that survive are curiosities, objects of historical attention, things to photograph. The people who built them are gone too, most of them, and the ones who remain are very old, and the specific knowledge they carried, how the welds felt under the right conditions, what a correctly torqued bolt sounded like, the precise angle at which the sponson bracket had to be positioned before the drill could go in, that knowledge is gone with them. What remains is the number. 22,234 vehicles. One every hour. For 4 years. That is not a human story. It is too large to be a human story. But it was made by human beings, one bracket at a time, one weld at a time, one shift at a time. By Dorothy Kessler at Station 14, with 40 seconds of margin and no intention of wasting any of it. By James Okafor, who understood without being told that reliability was a form of respect for the men who would depend on what he built. By Raymond Duchesne, who slowed the line for 3 weeks rather than sign his name to something he did not believe was right. These are the people who do not get monuments. The war produced enough monuments for the men who fought it, and that is as it should be. But somewhere in the accounting of how the thing was won, in the long, unglamorous arithmetic of production and logistics and precision manufacture, these names belong. They just never made it into the ledger.